Hello, welcome back to Mastering Statistics, Volume 7. What we're going to do now is start talking about the concept of Anova. This is a topic that is in the back of your statistics book. It's not difficult to understand, but there's a lot of components to it. So I want to give you a game plan here in the first lesson and give you an overview of what this really is. So I'm going to map it out for you. Basically, in this lesson, I'm going to give you an overview. I'm going to describe what Anova is in the big picture, right? And then over the next probably 3 or 4 lessons, we're going to calculate an ANOVA analysis by hand. It's not difficult, it's just tedious. So I'm going to show you how to do it so that you can really understand all of the formulas that go into it. Because ultimately you're probably going to use a computer program to do most of the problems in real life, like Excel, so Microsoft Excel. So what I'm going to do is teach you the equations and formulas by hand, at least with one long problem, so that you'll understand what the computer's doing. And then, most books just tell you to use the computer. So I could dump you in and just teach you Excel right now, press a button and get the answer, but you won't know what's happening or why it's doing what it's doing. So let's just jump into it now. You need to understand the concept of what's happening first. The big picture is that analysis of variance, even though it's got the word variance in here, and we'll talk about why it does in a second. Basically, we're going to be comparing population means, 3 or more population means. So I have a bunch of things I need to write down, I promise. If you just kind of stick with me, even though you have to invest a little time up front, you will come out with a really great understanding about what this thing is actually about. So we need to compare, and you'll see what I mean by compare in just a second, 3 or more population means. So I'll call this population means. Now I need you to think back to hypothesis testing in many lessons ago. Recently we've been doing hypothesis testing with variances, and you'll see how that ties in. But even before that, we did population means, hypothesis testing with population means, but we were always comparing 2 means, right? Now we're doing 3 or more means, and we're all going to do it with one test. So in the past, we might have done see if population A or population B, which mean is larger. We write the null hypothesis, the alternate hypothesis, and we have the data, or maybe see if they're equal or not equal. Now we're going to be doing a test, a very specific kind of test with 3 or more population means. So let me just write down an example of a null and alternate hypothesis. Basically, the null hypothesis for these things are always going to look the same. Population mean number 1 is equal to population mean number 2 is equal to ... because I'm not sure how many populations you're going to have in your actual problem. It's going to be 3 or more. But anyway, it's either going to be equal to the kth population mean. So there's k populations here, right? And don't worry, I'm going to nail this down with this very specific example so that you understand what I'm talking about. But basically, the null hypothesis is that all 3, in case of 3 or more, however many you have, they're all going to be equal to each other. When you see notation like this is equal to this is equal to ... equal to the kth population. That means if I have 3 population means, they're all equal. If I have 16 population means, they're all equal. If I have 7 population means, they're all equal. That's the null hypothesis, that all of the means are equal. So if that's the null hypothesis, then the alternate or the test hypothesis basically means, the way that you write this down is usually in words, that at least, and I'm going to write this down very specifically, at least one mean, one of these means that we're studying, differs from the others. Differs from the others. Okay, so basically every single ANOVA, at least of the type we're doing here in this class, that you're going to do is going to have the same null hypothesis and the same alternate hypothesis. So you don't really have to do that much thinking in terms of how to set up the null and alternate. The null hypothesis is always the same thing. It means all of these means are the same. Okay, the alternate hypothesis is the test or the claim that the researcher thinks might be true, is that at least one of these means differs from the others. So what we're going to end up doing is, you might be thinking, well, this thing is called analysis of variance. Why are we comparing population means, right? That was my first question. The bottom line is, when we get into the math, you're going to find out that we're going to use the concept of variance in order to study the means. So even though we're actually studying means, the technique is called analysis of variance because we're going to be testing how these means vary with regard to the other means. So how does mean number 1 vary or differ from all the other means? How does mean number 2 vary or differ from